Party people, ATCS, what's up? These are going to be a little walkthrough for how to do ways to climb. I've gotten the same question from about 5 students, and I'm fully aware this problem's hard and people are feeling a little overwhelmed, so I'm going to give you some hints on how to do this problem. So, just to recap the problem, basically you are a person and you have the ability to take small strides and long strides going upstairs. And the question is, how many different ways can you climb the stairs? So, just based on looking at this, you can probably figure out a whole bunch of combinations, but the question is, how do you actually successfully, with your programming skills, print out all the combinations? You'll note that this problem is going to be, I would say, a combination of left-right and Fibonacci. So we want to continually get closer to our simple case, but we also want to continually build up a string so that we can end up with these guys. So the first thing I would recommend doing, if you're not sure how to attack a problem like this, is write out some test cases. Write out some like examples, basically. So, and you'll note that you'll often end up with your base cases in this process. So, let's see. So I'll do this all in Courier New. So, ways of 0. All right, how many ways can we climb 0 stairs? There's not really any ways, right? No ways. All right, ways of 1. So in order to climb 1 stair, right, we can take a small stride, and you'll note that we cannot take a big stride. We would go over the top. I'm probably go up to maybe 4 just to kind of get the pattern here. So ways 2. So we can either take a small stride, and then we can take a second small stride, or we can take a large stride, and now we're at the top. Now you'll note that, and we're going to see this again and again, but this guy right here, right, after we take 1 step, we now have all the ways 1 up here, right? Or if we take a large step, we can do all this stuff up here, but I'll keep going on this process. So ways 3. So we can either take small step, therefore 2 left, right? And so that looks like this. So we take a 1 first, right? And then we can do this stuff here. So it would be 1 and then 1. Or we can do our small step and then this guy here, 2, right? Or we can do large step, then 1 left. And that looks like this. 2 first, and then all these guys up here, 1 left. Right, and that's it. Those are all of our options. And you'll note that if you just write it out on paper, these are indeed all of the options here. Right, and we'll do one more here. So ways 4, so small, then 3 left, right? And so that would be 1, and then all 3 of these cases, so 1, 1, 1, or 1 and then 1, 2, or 1 and then 2, 1, right? So you can see this guy here is really these 3. This guy here is these ones. And this guy here is these ones. Right? Or we can do large, then 2 left. So that'd be 2 and then right here 1, 1, or 2 and then 2. Right? And there's all of our options right there. So this is the part where it gets, when you do a bit of extrapolating. So this is pretty much every recursive problem. After you set up your base cases, which we'll do, right, you need to have a recursive definition for your problem. So, for example, with Fibonacci, right, for Fibonacci, maybe I'll just add a tangent at the bottom of the next page. For Fibonacci, right, we have base cases, then recursive case, right? Recursive case, right? For Fibonacci, this would be assume f of x minus 2 and f of x minus 1 work. Therefore, f of x is equal to f of x minus 2 plus f of x minus 1. Right? Now this step here, right, every recursive problem that you'll ever write is going to follow that general format. Right? You need to assume that something works, something closer to your base case works, and then you can just write your recursive definition. Right? Now there's a bit of a leap of faith there, but if you set everything up correctly, it works just great. So in this one here, right, assume Ways. Oh, I actually skipped a step here. I mentioned that this problem is similar to left to right. We're actually going to write a second method here, which is going to be, I'm just going to call it WTC for ways to count. Right? So the original one is going to take in a number. So for example, right, ways to count, right, it takes in a number. We'll say x, right? And what this is going to do is this is going to call WTC, my little helper method, right? And similar to left to right, I'm going to be passing in a string, right? And what this is going to do is this is going to continually add on a 1 and a 2 onto my string. And you can see that these guys here are all coming from this stuff up here. Alright, so my method header is going to look like this. It's going to be WTC of string s and int x, right? And x is maybe int steps, right? So I need to assume WTC of x minus 2 works. So x minus 2 and WTC of x minus 1 work. Then, therefore, WTC of x is equal to, right, this same structure over here. So it's equal to WTC of, so 1 in front of WTC of x minus 1, and a 2 in front of WTC x minus 2. Right, so there's my whole problem right here. This is kind of my general philosophy. So let's try to turn this into code. And the reason why I have this is so I can actually stick this in here. So this is going to basically get passed down from one function to another, from one recursive call to another. So going back to my code over here. So we got, there's a show header button on here. That totally works. You don't need the static. I'm going to get rid of it, but you can leave it as well. So we got WTC. You'll note that I'm just going to start off with a kind of a naive solution. I'm not going to worry about the commas or anything, right? I'm just going to worry about the general getting the number. So I want the 1, 1, 1, 1, 2, 2, 1. No commas, no square brackets, nothing. Right, so WTC of empty string and stairs, right? And here's my helper function, so public void WTC, right? String s, int x, or what did I call it? Stairs. So for this one, what I want to do is I want to first set up my base case. The base case is, right, so if, and we're going to go with our simple cases. So back over here, right, there's our base case right there. Right, if stairs is equal to 0, then similar to left right, right, this guy is going to get built up to what we want to eventually do. So we want to print it. And again, I'm not worrying about brackets, I'm not worrying about commas, right? And you'll note that, going back to our recursive definition over here, we need this to work for x minus 1 and x minus 2. So much like Fibonacci, we need 2 base cases. Otherwise, we're going to end up with infinite recursion on any number pretty much. So I'm going to code it for less than 0. So stairs is less than 0, right? We've now gone over the top of the staircase. This is impossible. So just return, right? Else if, right? Else. So this is where I want to do my recursion, right? And this is kind of my general philosophy. A 1 in front of x minus 1 and a 2 in front of x minus 2. Right? And you can see this string is going to end up getting all that stuff in there. So we want a 1 in front. Actually, yeah. So we want a WTC of whatever we built up so far. So S plus a 1. Right? And each time we call recursion, it's going to end up getting added on to the end of our string, which is good. And stairs minus 1, semicolon, and then also WTC of S plus 2, and stairs minus 2. And so there's pretty much my whole method. Right, so you can see we got our base case, where we'll be printing, right? We made it to the top of the stairs. We have our bracing for the impossible. You'll note that I could have a different base case for if stairs is equal to 1, right? Then I'd be printing S plus 1. That would work as well, right? And then I want to recur, just get closer to my base cases. So if I run this guy, you can see I basically have solved the problem, right? So 1, 1, 1, 1, 1, 1, 1, 2, 1, 2, 2, 1, 2, 1, right? I'll look at maybe one other test case over here. Right, if you look closely, you can see all this stuff is the same, right? I just haven't structured anything correctly. So the easy thing, stick on my square brackets. All right. And cool, so that's closer, right? And then we need to add our commas in. So let's just stick our commas right here. Right, and so you can see each time we add a number, right, we add a comma onto the end. And, oh, look at that. I was at 1 test case, now I'm at 0. Let's see what happens. So if we look closely, you can see we have most of this, right? The only issue is we have this extra comma on the end, right? And the question is, how do we get rid of that? And I would say there are 2 ways to do it. One is with some sneakiness up here, which I'm not going to delve into that. The easy way is we have this string that we built up, right? So what we want to do is we want to just rip off the last 2 characters, right? So this is, each time we're printing, it's going to be on this line. So just rip off those last 2. So dot substring 0, comma, s dot length minus 2. Oh, buddy, we're getting closer. So let's see what we got. So all these pass. Let's see. So we have an index out of range, and this is for ways to climb 0. So let's see what's happening there. So if we pass in 0, S is empty string. So we're over here. And, oh, I see what's happening. It looks like we're calling substring of s.length, which is 0, minus 2 is 2. So in that specific case, this crashes. So let's see what they even want here. If there are no ways to climb 0 stairs, so let's see. There are no ways to climb 0 stairs, so your method should produce no output if 0 is passed. Okay, so let's see, how do we handle this? A couple different, I would say you can add some stuff in here to see, there's a way to handle it here. I'm not going to delve into that. I'm just going to do the easy solution. If stairs is equal to 0, or maybe not equal to 0, then we do this. Right, and you can see, right, we didn't print anything there and everything else worked just great. So, big takeaways here. Takeaways. You will often need to write a second method Okay, that's a big one. Additionally, you will often there's a step in here where you need to assume that your other cases work. You will need to assume, or maybe suppose. Yeah, you need to assume that your other cases work. Right? Then write your code to get closer to the base cases. Right? And what I mean by this is, in this case, right, when we passed in, for example, 30, right, I don't know that, like, in order for WTC of 30 to work, I need to assume that WTC of 28 and 29 work. Right? I have not traced to that point. But what I do know is that WTC of 28 and 29 both, each time through, right, they get one step closer or two steps closer to our overall base case, right, or base cases in this case. So those are kind of the big suggestions. Good luck. Happy coding.